next question, number 7. Now the question reads, C0 is the capacitance of a parallel plate capacitor with air as dielectric, as in figure A. So here we have C0 is the capacitance. If half of the entire gap, as shown in figure B, is filled with the dielectric of permittivity epsilon r, the expression for the modified capacitance is, so we have our 4 options given to us. Now in order to solve this problem, we will have to take a look at both the figures, figures A and B. Now if we have to take a look at figure A first. Now for figure A, let's write down the expression for capacitance. Now the general expression is the area multiplied by the permittivity divided by the separation between the plates, right? So the expression is A epsilon by D. Now since here we have the capacitor that has the dielectric of air, we can call this as A into epsilon naught divided by D. So this is the expression for capacitance for the first figure. Now let's consider the second figure. This is for figure B. Okay. Now for figure B, the question says that half of the gap is filled with a different dielectric, and the dielectric has the permittivity of epsilon r. Now what would be the equivalent capacitance? So we have to find out what is C equivalent. Now C equivalent, when we have an arrangement like this where half of it is filled with the dielectric of air and the other half with another dielectric, the modified capacitance would be C1 plus C2. Considering this is C1 and this is C2. I hope that makes sense so far. So we will have to note down the expressions for C1, C2 and then solve further. So C1 is the part of the capacitor which is filled with air. So the expression would be, let's write it as A1 epsilon 1 by D. Now the separation between the plates is anyway the same for both the parts of the capacitor. So D will remain the same for both the capacitance C1 and C2. Now in case of C2, let's write this as A2 epsilon 2 by D. Okay? Now the first part of the capacitance here, A1 epsilon 1 by D, the only difference is now A is going to be the same for both. The area of the plates is the same, right? So this here, we're going to write this as A by 2. Why is it A by 2? Because half of the capacitor is filled with one dielectric while the other half is filled with the other two. So the area of the plates is now halved. So here for C1 it is A by 2. For C2 also it is A by 2. Now the permittivity of the first part is epsilon naught. So let's write that as epsilon naught. The distance is anyway D. Plus, let's take a closer look at part C2 now. For C2, the area is A by 2. The permittivity is epsilon r. So we note this down as epsilon naught into epsilon r divided by D. I hope that is visible and clear as well. So here we have C2 to be A by 2 into epsilon naught epsilon r by D. Let me just grab another sheet of paper and I'll note that down a little clearer. Okay. So far we have C equivalent, which is C1 plus C2, and we have noted that down as A by 2 epsilon naught by D plus A by 2 epsilon naught epsilon r by D. Now what can we take common here? We can take A epsilon naught by 2D common and we are left with 1 plus epsilon r. Is that right? Now what is A epsilon naught by D? We have noticed this down in the very beginning here. A epsilon naught by D is C naught. This is the part of the capacitance for figure 1, if you will notice, right? So we are substituting that part here. So we can note this down as C naught divided by 2 into 1 plus epsilon R. So this is the modified capacitance of the capacitor given to us in the question. So that's C naught by 2 into 1 plus epsilon R. Let's check and see which it matches. It matches option A. So this is the final answer.